Hello everyone. Okay, let's see the okay. Today we are going to learn a simple and important topics in compiler design. The topic is phases of a compiler. First, let us understand what a compiler does. We write a program in high-level language like C, C++, or Java, but the computer cannot directly understand that full programs like us. So the compilers converts our source program into target code or machine code instructions. Please think of a compilers like a language translator. Okay, so what language translator will do, we give one language as input and it give other language as output. Okay, but it does not do that in one single steps. It check the program step by step. It check the program step by step, like it check the words, it check the grammar meaning, and then it's create courses. So in these presentations we will see six main phases. Lexical There are lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, code optimizations, and code generations. We will learn each phases with simple examples. Okay, so let us see the full compiler pipelines. Compiler work like a production lines. So like each phase take inputs from previous phases and give output to the next phases. First, the source code goes to the lexical analyzers. Okay, so this phase break the programs into tokens. Okay, the lexical analyzers break the programs into tokens. Next, syntax analyzers check whether the tokens are arranged in the correct grammar or not. In syntax analysis phases, it check the whether the tokens are arranged. Where we are getting the tokens. The tokens are generated by the lexical analysis. Okay, the tokens are arranged in the correct grammar or not, that has been verified by the syntax analyzer. And next phase called semantic analyzers. Semantic analyzers check the meaning of the programs. For examples, it check whether the variables are declared and whether the data types are correct or not. So it's like that of error checkings and all done by the semantic analyzer. And next, then compiler create the intermediate codes. Intermediate code is like a mid-level codes. It is easy for compiler to handle. After that, optimizations improve the codes. It tries to make the code faster, shorter, or better. Finally, the code generation converts the optimized code into target machine code. So remember these flows. Source code goes in after many checks and changes, and target codes come out. And next slide. The first phase is a lexical analyzer. Okay, so lexical analyzers also called it as a scanning. The tool used in the phase is called lexical analyzer or scanner. Okay, in this phase, compilers read the programs characters by characters. Then it groups the characters into meaningful units called tokens. Let's take some examples. Okay, take the statement int count equal to 10, or the statement int count equal to 10. Here int is a keyword, right, and count is an identifier. Okay, the equal sign is an operator, and 10 is a number, and the semicolon is a special symbols. All these are tokens. So lexical analyzers also remove extra spaces, tabs, and comments, because those things are not very useful for the next phases. Okay, you can also find simple errors. For example, if the program has an invalid characters, the lexical analyzers can report an error. So the main job of lexical analysis is very simple: convert raw characters into tokens. Let's see the next phase, syntax analyzer. Okay, the second phase is a syntax analyzer. Syntax analyzer is also called a parsing. Okay, the tool used in the phase is called parser. So it's in every phase we use some tools. In previous phases we use a scanner. Like similarly in syntax analyzer we use the tool called parser. Okay, so after lexical analyzer the compiler has a token, right? Now the parsers check whether these tokens are arranged in the correct order. This is similar to grammar in English. So words may be correct, but sentence must also be in a correct order, right? So in the program also, token may be correct, but statement structures may be wrong. For example, a missing semicolon, a missing brackets, or wrong expressions format can create a syntax error. The parser also create the parser tree or syntax trees. Okay, the tree shows the structure of statement. For example, in a plus and multiplication expressions, the tree helps to show which operation should happen first. Okay, so lexical analysis check token, syntax analysis check grammar and structure. The third phase is semantic analyzer. The word semantic means meaning. So, semantic analysis check the meaning of the program. Please understand one important point here. A statement may be grammatically correct, but still it may be wrong in meaning. For example, suppose we declare a age as an integer, okay? Then we try as in a value, as in a word 22 age. Okay, what will happen? The structures may look correct, right? But the meaning is wrong because a string value is given to an integer variables. So semantic analyzers check the kind of problems. It check whether the variable is declared before use. It check whether the data type is correct. It check whether the function is called with the correct number of arguments. It also checks scopes, which means where variables can be used. Okay, so this phase uses the symbol table heavily. Okay, the symbol table stores details about variables, functions, data types, and scope. Right. So semantic analyzers make sure the programs really make sense or not. Right. Okay. And then the fourth phase is the intermediate code generations. After compiler understand the program, it does not always directly create the machine codes. Many compiler first create a mid-level courses. This is called intermediate code or intermediate representations. Why do we need this intermediate code? Because it is easy to analyze, easy to optimize, and easy to convert into different machine courses. One common intermediate code format in three is a three addresses code. Let us take the examples. A equal to B plus C into D. The compiler may convert it like this. First, T1 equal to C into D. Second, T2 equal to B plus T1. Third, A is equal to T2. Here, T1 and T2s are temporary variables created by the compiler. This makes the expression simple step by step. Okay, so intermediate code generations convert the program into simple machine independent form. Okay, so these intermediate code generations convert the program into machine independent form. And next phase, the fifth phase is called a code optimizations. Okay, optimization means improving the code without changing its meaning, right? The output of the program must be the same, but the program should run faster and use less memories or become smaller. Okay, for example, if compiler sees x equal to 3 into 4, it calculates it's during the compilation, right? So it can replace it with x is equal to 12. Okay, why you want to give a two different values like x equal to 3 into 4? Instead of 3 into 4 we can give a direct results 12. This is called as a constant floating. I'll tell you another examples. X plus 0. Okay, what will happen if you're giving x plus 0? Adding 0 does not change the value, right? So compiler can remove that extra operations. Sometimes the program may have code in that never uses. Okay, the compiler can remove that also. This is called as dead code eliminations. Okay, so optimization is very useful because it improves the performance, but the compiler must be careful. It should not change the final results of the program. Okay, and next slide. Sixth phase is called code generation. This is the final major phase of the compiler. Okay, so in this phase, the optimized intermediate code is converted into target code. The target code may be assembly code, machine code, or byte coded. It depends on the programming language and the systems. Okay, so code generation is not just simple word by word translations. The compiler has to decide which machine instruction should be used. It also decide where value should be stored. Okay, and some values may be stored in registers. Some values may be stored in memory. Okay. So registers are very fast, but they are limited. So compiler must use them carefully. This is called register allocations. The code generator also consider the target processes. Okay, like different processes may have different instructions. So the final code is target machine independent. In simple word, if I want to tell you, code generations converts the improved intermediate code into code that is the machines can execute it. Okay. Now let us take one simple examples and pass it through all the phases. The statement is sum equal to plus b into 3. So in the first phase of compiler called lexical analyzer, the statement is broken into token like, so sum is an identifier, equal sign is an operator, assignment operator, a and b is our identifier, plus and multiplication is the operators, 3 is a number, semicolon is a special symbols. This is what we'll get from output of lexical analyzer, and these output is given to the input as a syntax analyzer because it's a pipeline, right? The parsers check whether this is valid assignment statement. It also understand that the multiplication has higher priority than additions. So b into 3 should be happen before adding a. Okay. And then it will move on to the next phase called semantic analysis. In semantic analysis phases, compiler check whether some a and b's are already declared. It also check whether the data types are compatible. Okay. Then it move on to the intermediate code. Intermediate code is created. For example, T1 equal to B into 3, T2 equal to plus T1, and sum equal to T2. After optimization, the code may be improved if possible. Finally, code generations create target instructions. Now let us see two important support component. They are symbol tables and error handling. Right? So there are not exactly separate phases, but they support many phases of the compiler. The symbol table is like a small databases inside the compiler. It stores information about names used in the program. For example, so when we declare int age, okay, the symbol tables can store the name, age, its its data type, its scopes, and its memory locations. Okay. In semantic analyzer, semantic analysis phases, semantic analyzer use the symbol table to check whether the variables are declared. Code generator may use a symbol table to know whether the variable is stored. Okay, so error handling is also very important. Mm, Compiler should not be simply stopped for every small mistakes. It should show useful error messages also, right? So there can be a lexical error, there can be a syntax error or semantic error, or sometimes other compiler related errors, right? So good error handling helps the programmers to find the correct mistakes easily. Okay? These are the two phases. And then other easy way to understand compiler by dividing it into three parts. There are front end, middle end, and back end. The front end is related to the source languages. It includes lexical analyzer, syntax analyzer, semantic analyzer. These three phases will comes in the front end. Okay, so its job is to understand the program. It check the tokens, grammar, and meaning. The middle end works mainly with the intermediate code and optimizations. It tries to improve the programs without depending too much on the final machines. And the backend is related to the target machines. It generates the final target codes. It chooses instructions, registers, and memory locations. So this division is very useful in compiler designs. For example, if we want to support new programming language, we may change the front end. If we want to support the new processors, we may change the back end. So these structures make compiler designs more flexible. Okay. And these are common errors in the phases. This slide shows the common errors in the phases. Let us see one by one. Lexical analysis may be individual characters or invalid tokens. Okay, syntax analysis, the error is related to grammar. For example, missing brackets, missing semicolons, or wrong statement structure in syntax error. In semantic analysis, the structures may be correct, but the meaning may be wrong. Okay. Intermediate code generation and optimizations are mostly internal compiler activities, but we study them to understand how compiler changes and improve the programs. Okay, so when we get a error, we can try to identify which phase is responsible for the errors. And this is some classroom activities. Okay, we consider the activities. Let's take the assignments total equal to price plus tax into. Okay, and then takeaways. So what compilers do? Compilers convert the source into target mode. It does not do everything in one step. It follows the different phases: lexical, syntax, semantic, intermediate, core optimizations, core generation. In lexical analysis, convert the characters into token. In syntax analysis, check the grammar and create structure. In semantic analysis, check the meaning, data types, declarations, scope. In intermediate core generators, create the simple missions dependent form. Okay. In code optimizations, improve the code without changing the meaning. In code generations, convert the optimized code into target machine instructions. Okay. So also remember simple tables and error handling. The simple tables store the important information about variables and functions. Okay. Error handlers help the programmer understand mistakes. So compile is not a magic. Okay, semantic processes. Each phases has a clear jobs. So when we understand these phases, compiler design become much easier. Okay. So thank you everyone. In next sections, we will take one more examples with the practicals, each phase out step by step. So thank you guys.